Let's talk about foundations. Now, if you open up any algebra book, you start with chapter 1 and you find that you have all these fancy words, and you may read on and you might see fancy words like commutativity. And then when you read about what that means, you realize that it's something that you already know. Things like A times B is the same thing as B times A. You can switch places. But you already knew that when you first memorized the times table. For example, when you remembered what 3 times 7 is, and later you find that that's the same thing as 7 times 3. They both give you 21, right? So you get a little bored thinking, oh, these are just fancy names to things that you already know. But there are some things that you may not have known, or you may think you know, but you don't. And one such example is the distributive property, which says that if you multiply A to B plus C, you get AB plus AC. It's called distributive because A times B, A times C, A is being distributed to both B and C. Now this direction of calculation, this process, is what we call expanding, because this short form was expanded in a longer form. On the other hand, in math, you can always switch the left and right, and it should still equal. If you have an equal sign, you can switch the left and right. And the above means that not only you can expand, but you can also do the reverse. If you have something expanded, you can make it into a short form like that. And if you look at what happened here, you see that A and this A, these are common factors of these two terms. In that case, you can just write A once, and you can have B plus C inside. And this process is what we call factoring, because A and B plus C are separately factors of this single thing. This expression is divisible by A, and it's also divisible by B plus C. That's what it means. Now, you may even think that you knew this already. However, let me give you a question and see if you can answer this. And if you can really answer this easily, then you truly know this, okay? Alright, here's a simple arithmetic problem. 7 times 23 plus 7 times 27. Can you do this in your head? That's my question. Now stop the video and see if you can do this. Okay, so I will assume that you stopped the video and tried this. If you try to solve this by doing 7 times 23 and you got 161, and if you try to do this by 7 times 27, which is 189, and you try to add them, well, then you truly didn't know what this meant. This distributive property, written this way, really means that if you have a common factor, you can factor that out. You can factor it, and the remaining numbers are 23 and 27, so you have 23 plus 27. What is 23 plus 27? Well, that's 50, right? And then you end up with 7 times 50, which is 350. And if you did it this way, then you could actually do the entire calculation in your head very easily. Okay? Now, if you try to do it this way, you can still add them and get the same answer, 350. Well, that's quite amazing too if you were able to do this in your head. But I would say that doing this way would be showing more understanding of the distributive property. Okay, here's another property that we see. It's called multiplicative inverse. So I'm skipping a few things. I'm not going to explain every word in the first chapter, but you should know that the multiplicative identity is 1, and multiplicative inverse is such that when you multiply them, you do get 1. So for example, if you have 3 over 7, the multiplicative inverse is 7 over 3. The reciprocal, the fraction that you get by flipping the top and bottom, that's called a reciprocal. If you multiply them, you get 1. Now let's try to check that this is true. How do you multiply fractions? It's top to top, bottom to bottom, right? So 3 times 7 is 21. 7 times 3 is 21. And indeed, this does give you 1, right? Okay. And if you have an integer, the reciprocal is 1 over that integer, right? That's also 1. Now the implication of that, the fact that multiplicative inverses are really reciprocals, is the following. Let's say you have some number and you've divided by 5 and then multiplied by 5 again. And we all know that division and multiplication are opposite operations, so if you take some number and divide by 5 and multiply by 5 again, you get the same number again, right? On the other hand, if you know that 1 over 5 is the multiplicative inverse of 5, then these two multiply to 1, and 1 times anything is itself. 1 is the multiplicative identity, so it's again A. Now what that tells us is this important principle that division by a number is same as multiplication by its reciprocal. Okay, here's an example. Let's say you're trying to divide 4 by 2/3. Well, you should know that the symbol for division really comes from fractions. So if you had this fraction written like with small numbers and a big bar and another small number, right? And if you stepped 10 feet away from the screen and try to look at this, these two will look pretty much the same thing, right? So division sign comes from a fraction and vice versa. When you have this bar, that really means it's 4 divided by 2/3. Okay, and then we apply the above principle, which says division by a number is same thing as multiplication by its reciprocal. And how do you multiply an integer to a fraction? You write it as 4 over 1 and times 3 over 2. First write that down the integer as a fraction, then again it's top to top, bottom to bottom. So 4 times 3 is 12, 1 times 2 is 2, 12 divided by 2 is 6. So that's the answer. Alright, now how do we calculate the sum or a difference of a fraction? So let's talk about that. Adding fractions. So let's say you have 3 over 5 plus 1 over 4, and you wanted to add these two things. Well, you're told that in order to add two fractions, you need a common denominator. Okay? That's only for addition. Multiplication, you don't need it. Only when you add, you need common denominators. And to get the common denominators, you have to multiply some number top and bottom to get the same, or to get the least common multiple of the two denominators. So 5 and 4, the least common multiple of 5 and 4 is 20. 20 is the smallest number that's divisible by both 5 and 4. So we have 4, 4, we multiply 4 top and bottom, 4 times 5 is 20, plus 1 over 4, and then for this second one we multiply 5 top and bottom, 5 times 4 is 20. And if you do that, you end up with 12 over 20 plus 5 over 20. Okay, and then you're supposed to add, but I want to take a few more steps in order to understand why it's possible to add two fractions when you actually have common denominators. Okay, first remember that 12, this is 12 divided by 20, but 12 divided by 20 is same thing as 12 times its reciprocal. So 12 divided by 20 is same thing as 12 times 1 over 20, plus the same thing can be applied to the second one and say this is 5 times 1 over 20. Now we see that 1 over 20, 1 over 20, these are common factors of the two terms, and therefore you can factor the 1 over 20 out using the distributive property. That's the fancy name for this factoring thing. It's just factoring. Okay, and then you have 12 plus 5, which is 12 plus 5, that's 17. So you get 17 over 20. Now I am showing these two extra steps just because I want you to know that the reason you're allowed to add two fractions when you have the common denominator is basically because of the distributive property. You can factor it, okay? But when you do that, people just skip from here to there because it's just assumed, right? When you have a common denominator, you just have to add the top. 12 plus 5 is 17 and you're done. So you can go straight from here to there without going through this. And I just want to demonstrate to you that the fundamental properties of numbers that we learn, things like distributive property, commutativity, associativity, and stuff like that, those are very important. Okay, now I want to just make a note here that while distributive property, when you understand it as like you distribute one thing to two of the items inside the parenthesis, it's often misunderstood that you can do it even for multiplication. Okay. However, a times b times c is not equal to a times b and a times c. It's equal to ab. You only get to multiply to one of them, not both. And then c gets multiplied once. And this identity is called associativity. And it basically means that the order of multiplication doesn't matter. You can multiply b times c first, and then you can multiply a, or you can multiply ab first, and then you can multiply by c. So that's what associativity is saying. But unfortunately, many people fail to distinguish between the associativity and distributive property. Distributive property only works when you have additions. Okay, now let me do some examples or tips. So here are some tips. When you have a number and you're subtracting from it something larger, then try to factor the negative out. in this example, it just becomes, if you factor the negative out, it just becomes addition. So you get negative 11. But I think a lot of people have trouble with something like this. If you have, say, 5 minus 12, how do you do this? Well, you pull the negative out, and that's like negative 5 plus 12, which is minus 12 minus 5, right? You can switch these two around, and that becomes 12 minus 5, and that's equals to negative 7. So when subtracting larger number from a smaller number, you should try these strategies. Now, if you get more comfortable with this method, you can do something like this. You can just say, let's say 7 minus 19. You can switch these two around and say 19 minus 7 and put a minus. Okay, this is a very good strategy. If you have a small number and you try to subtract a bigger number, put a minus and switch them around. Okay. In other words, what I'm trying to say is that a minus b is same thing as minus b minus a. Okay, that's like a good formula to use. Another tip is about for simplifying complex fractions. Suppose you have 3 over 4 plus 1 over 2 over, say, 5 over 4 plus 1. Now, a lot of people will try to do it this way. Let me show you the longer way. They would look at this and try to simplify the top and then simplify the bottom. To simplify this, you want to make it into a single fraction. That will require you to have common denominators. And, well, 2 and 4. What's the common denominator of 2 and 4? Well, we're looking for the least common multiple, right? And since 2 times 2 is 4, 4 is the least common multiple. So you multiply 2 top and bottom. And for 1, you can rewrite as something over 4, right? Well, what's something over 4 that's equal to 1? Well, if you divide 4 by 4, that's 1, right? So you can rewrite it like 3 over 4 plus 2 over 4 over 5 over 4 plus 4 over 4. And then now that you have common denominators, you can say this is like 5 over 4 divided by 5 plus 4 is 9 over 4. And then we use the trick that division, this is division, right, is same thing as multiplying the reciprocal, 4 over 9. And then you multiply by top to top, bottom to bottom. 5 times 4 is 20. 4 times 9 is 36. And then you realize, well, 4 goes into 20 evenly, and also 4 times 9 is 36. So if you divide top and bottom by 4, you end up with 5 over 9. Or you could have done it even simpler way by looking at 4 and 4 and being able to cancel. If you did that, you would get 5 over 9 immediately, right? Okay, but that's the long way. The tip for calculating this quickly is to realize that, well, if I multiply by 4, then all the denominators will disappear. So you look at the fraction, complex fraction, and think about what number you should multiply top and bottom in order to make it simple, in order to make the denominators go away. Okay? In this case, it's 4. Now, in a fraction, you're allowed to multiply anything to top and bottom. You can multiply 8 at 8 or 10 10, it doesn't matter. That's because multiplying 4 over 4, what is 4 over 4? That's 1, right? So if you multiply by 4 and divide by 4, that has the same effect as multiplying by 1. So that's why you're allowed to put any number on top and also any number on the bottom. Okay, then we use distributive property. We expand. And you say 3 over 4 times 4. Well, 4 cancels, and that just leaves you just leaves you with 3, right? And then 1/2 times 4. 4 divided by 2 is just 2. And down here, 5 over 4 times 4. 4 cancels. And 1 times 4 is just 4. So you have 3 plus 2 over 5 plus 4, which is 5 over 9. Okay, and that's a lot easier than trying to do what's above. Okay, we covered the most basic things. I would like you to have some understanding, but what's really necessary after having the basic understanding is lots and lots of practice. It's especially important that you can do these things, a lot of the steps, mentally, because once you train your mind to do these mental math, then things become simpler to you because your brain is trained. So just try to work hard, solve a lot of example problems, and you will find this part very easy.